Hi people, it's good to see you again. And now we're looking at part 5, where you're just doing revision and adding all the different types of attachments, and also looking at 1, 2, or 3 question papers, examples in question papers. Right, so if we look here, you'll see that we have a sample example. And what we must remember, that we're always identifying the longest chain first. So if you look at this example here, here's your longest chain. This is a short chain, and so this is just a branched group consisting of 1 carbon. So this forms part of the prefix. So the prefix here then being 1 carbon, that's then meth, and the branch, a suffix is -il, so it is at carbon 2. So it's 2-methyl. Being 3 carbons, then it's prop. These are single bonds, so it's an alkane. So then the IUPAC name will be 2-methyl propane. And here I've indicated that the prefix consists of your attachments. You have to identify where you find the attachment, and you start on this side. It would not have mattered if we started left or right, so I started from the right side. So it's number 2, carbon, 2-methyl propane. Prop is then your root word, and ane is your suffix, being an alkane. Here's the condensed formula, CH3, CH. Your branch group is then in brackets, and CH3. Right, if you look at the next example, here we have 5 carbons. This is your longest chain. So it's pent. This is your root word, pent. And ane, because it's single bonds, because it's an alkane, it's the suffix is ane. And then on the 3rd carbon, we have 2 carbons attached with their hydrogens. So it is then 3-ethyl pentane, pent being the root word, or ethyl. I hear many people speak of ethyl, ethyl or ethyl pentane. And then also it's got a condensed formula that I wrote down here. All right, so I just recalling that your branched group is then in brackets. So it's C2H5. This is then C2H5. Right, let's look at the next example. Here we have 4 carbons. We've got 2 attachments. So there's 2 attachments of an ethyl or ethyl. So it's di, and it's on carbon 2 and carbon 3. Right, it would not have mattered if I started 1, 2, 3, 4 from the right-hand side. It would have come down to the same 2 numbers. So it's at carbon 2 and at carbon 3, you've got an ethyl or ethyl. So, methyl or methyl, and it's then dimethyl, right? Butane, because it's a single bond, the suffix. But being the root word. Right, the next example, we identify immediately that there's 4 carbons. This is your longest chain. This time it's an alkene because it's a double bond. And we've got an attachment on the 3rd carbon. Remember that you always start numbering the carbon from the side of the functional group. So it's 1, 2, 3, 4. So your attachment is at number 3. So it's 3-methyl but 1-ene. Or because it's at the 1st carbon, you could have written it as butene. Good. Next example. Again, here we have a double bond, so it's immediately butene. It's an alkene. It's 4 carbons, butene, but it's an alkene. We start numbering from the left because the double bond, the functional group is on the left side. On the 3rd carbon, we've got 1 attachment, 1 carbon attachment, so it's methyl. So it's 3-methyl butene. All right, and then I've written down your condensed formula here. You'll see it's CH2, CH2, because you've got CH and CH, so you can write it as CH brackets 2, and then CH3, that is your attachment, that is total, the total CH3 is in brackets. Note that the 2 here is outside the bracket because it's 2 CHs, but here you've got 1 CH3, and then you've got your CH3. This is your condensed formula. Right, the next example, we've got the functional group on the left-hand side, the alkene, but also on the right-hand side. All right, so we always start with the number closest to the carbon. So in this example, I've started from the left side because the attachment is also closer to the left-hand side. And there's 2 carbons attached here. So it will be an ethyl. Right, so there's 4 carbons, but 2 functional groups. So we have to identify the prefix being the attachment. So it's on carbon 2. So it's 2-ethyl, that's your prefix. Your root word is your number of carbons from your longest chain. In this example, it's actually easy to identify the longest chain. So it's but. And then you've got on carbon 1 and on carbon 3. On carbon 3. Right, I see that I've written here carbon 3. It should actually be on carbon 4, not 3. It should be 4. Apology for this. I don't know where and why I wrote here 3, but if we look at this, this is 1, 2, 3, 4. So this one should be at number 4 and not at number 3. So please note that this is not correct. It should be 1 and 4. 2 of them die in, and that is the suffix of the functional group being an alkene. So please note this is a 4 and not a 3. So it's at carbon 1 and at carbon 4. You've got your diene and your but and your 2-ethyl for your prefix. Right, so remember this is at carbon 4 and not at 3. Right, the next example here, we've got an alkyne triple bond and we've got 1 attachment. Again, you start numbering from the right-hand side, and so it will be at carbon number 2. That's from the right-hand side. Your attachment is then at carbon 5. So you've got, and you have to acknowledge that your attachments is part of your prefix. So it's at carbon 5 and it's 1 carbon methyl hex because of the 6 carbons. And where's the triple bond? It's at carbon number 2 ine. So it's 5-methyl hex 2 ine. All right. So again here, we've got our CH3, our C, another C, and then CH2, right, there's your CH2, and then you've got your CH3 in brackets. Okay, sorry, no, first the CH, there's your CH, there's your CH2, that's your CH2, then you've got your CH, and then you've got your CH3 that's in brackets, and then your CH3, there's your CH3. So it's 5-methyl-hex-2-ine, being a triple bond. Right, the next example, we have got a bromo and chloro, and we've got an attachment of 1 carbon, and we've got 5 carbons. So we start numbering the carbons from where we have where we are the closest to the functional size, being haloalkanes here, and an attachment. And then we have to order it in an alphabetical order. We have to put it in an alphabetical order. So B, and then C, and then M. So bromo, bromine that becomes bromo is at carbon 3. Chlorine that becomes chloro is at carbon 2. And then at carbon 2 as well is 1-methyl. It's pent, being 5 carbons. It's single bonds, being ane, alkane. So you've got your prefix, your root word, and then your suffix. Right, the next example, we note that here it would not have mattered on which side we started numbering. I started numbering from the right-hand side, 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. It would have stayed 3 here. So it would not have mattered if we numbered it from the left side, but I numbered it from the right-hand side. So you've gotten chlorine. No, sorry, if we recall this, look, chlorine is on the right-hand side. Sorry, I didn't see that. So because chlorine is on the right-hand side, that is why I numbered it from the right-hand side. So C then becomes alphabetically first. So it's 2-chloro, carbon 2, chlorine, 2-chloro. Then we've got 2 attachments on the same carbon. You have to identify each one separately. So it's 3 for this one, another 3 for the top one, and it's 2, that's methyl. So there's 2 branches with 1 carbon each, and they're both on the 3rd carbon. So you have to acknowledge both of their locations. So it's 3 and then another 3 for the other methyl. Di being 2-methyl pentane. Normal single bond, so it's an alkane. Therefore, it's pentane, the suffix being ane. So it's 2-chloro, 3,3-dimethyl pentane. Right, next example. Here we've got a triple bond on the right-hand side, and then your attachment. The attachment always takes the lowest number, but your functional group takes preference. So it overrides the placement of your attachment. So you first give preference to your functional group. So therefore we numbered it from the right-hand side, 1, 2, 3, 4. So we put it in alphabetical order. Now here we don't need to, there's only 1 branch. And the branches are part of the prefix. So it's on carbon 3, methyl, but, right, being 4 carbons, 1 ine. So it's at the first carbon, and because it's at the first carbon, you can also write it as 3-methyl-butane. Right, here's your condensed formula, being the attachment again in brackets, showing the attachment in brackets. Right, the next example, we have 3 chlorines attached. Right, so it's trichloro. We've got an attachment here, a branch here on the 3rd carbon. So we start numbering from the left side, because chlorine being the closest, here the functional group, the haloalkane. So it's at 1. Then there's 2 at carbon 2. You have to acknowledge the 2 2s. Trichloro. 3 methyl, because remember this branch group is at the 3rd carbon. Being 3 carbons, it's prop. Being single bonds, it's an alkyne, so it's ane. So you have 1, 2, 2, trichloro, 3 methyl, that's all part of your prefix, your root word being prop, ane being your suffix. Right, next example. So here we've got an OH. So immediately we have to identify it as a alcohol. We've got an chlorine and we've got 1 carbon branch here. Right, now we can put it in alphabetical order. Remember, it's an alcohol. So an alcohol suffix being ol. So here we have chloro at number 2, 3 methyl, but for the 4 carbons. And at the 1st carbon, we've got the alcohol, so it's ol. So it's 2 chloro, 3 methyl, button ol, or button 1 ol. All right, this branch here, this functional group here being an alcohol, and the suffix of the alcohol is ol. Right, next example. Here again, there's 2 where we are going to look at the examples where we have an alcohol. So here we have 3 carbons. We start numbering from the functional group. So it's then prop being 3 carbons. At the 2nd carbon, we have got a branch with 1 carbon. And it's, as I said, at the 2nd carbon. So your prefix is then your 2 methyl, 3 carbons is prop, and then the alcohol is ol. So it's propan. Remember the E becomes ol, propanol. So it's 2 methyl propanol or propan 1 ol. So something I want to say, remember, I'm not indicating the longest chain, but this is your longest chain. I'm not indicating it every time at each example, but this is your longest chain. And the longest chain doesn't always need to be in a straight line. I didn't do an example here where you can get it, where the longest chain can go down or the longest chain can go up, but the examples that I chose here are all in a long chain, are all in a straight line. It doesn't always need to be in a straight line. It can change. All right, so let's look at the next example. Here we have a 5 carbons. We've got a functional group of OH, so we know by now it's an alcohol. So the suffix will be ol. We've got 3 carbons as a branch. So we know it's meth eth prop. So it's on the 4th carbon. So it's 4 propyl pentan 1 ol or pentanol. So it's 4 propyl pentanol. On the 1st carbon, you've got your functional group. As an alcohol, it's ol. All right. And you've got 3 carbons here. So it's propyl. Remember the suffix at the attachment, the branch is il. Right, so here we see a different suffix, and immediately you must recognize it as a carboxylic acid. Remember the suffix is then C, double bond OOH. It can also be written as COOH. And then the suffix is oic acid. So this is an carboxylic acid suffix with an attachment here, with a branch here. So you start numbering from your functional group. You've got 5 carbons, so it's going to be pent. Your branch group is at the 3rd carbon. Remember, your branch group is part of the prefix. So it's 3 ethyl pentan 1-oic acid. You can also say it's 3-ethyl pentanoic acid. Being at the first carbon, you don't need to write the 1. You can just say pentanoic acid. So the substituent takes the lowest number, but the functional group gets the preference, as in this example. So the functional group gets the lowest preference as number 1, and then your substituent group takes on number 3. Right, so this is an example where we have COOH as a suffix, being a carboxylic acid. Right, so here's another carboxylic acid compound where we've got 3 carbons, and it's written as double bond OOH. So it starts on the right-hand side. You number it then 1, 2, 3, because there's a fluorine on the 3rd carbon. We know fluorine becomes fluoro. So it's 3-fluoropropanoic acid. Propan, 1-oic acid or propanoic acid. So it's 3-fluoropropanoic acid. Right, now remember the difference between a carboxylic acid being C double bond OOH and an aldehyde being C double bond OH. Right, so you have to be able to distinguish between these 2 functional groups of the carboxylic acid the moment you start with branches as well to give the IUPAC names. So remember, these are all IUPAC names. I didn't write it down, but they are all the IUPAC names. And here we've got a C double bond OH. That's an aldehyde. And we've got 2 branches here as well on number 3. So again, your prefix being your branch groups, and they also get the lowest number, yes, but your functional group overrides that rule. It gets the preference. That's at number 1. So it's 3 for the 1A methyl and 3 for the other methyl, the location. And it's 2 of them. So it's 3,3 dimethyl, 4 carbons being butane 1. And remember, the aldehyde is Al or Al. Where the alcohol is Ol, the aldehyde is Al. So it's 3,3 dimethyl butanol or butan 1-al. So the aldehyde, it's easy to remember if you just recall the Al of aldehyde as Al, but not a capital letter. And it's C double bond OH, where your carboxylic acid is C double bond OOH. So please distinguish between that. Right, another example of an aldehyde is where we've got now a chlorine, we've got a bromine, we've got a branch of 1 carbon, and then we've got our double bond OH. So remember, this is your functional group of your aldehyde. Right, so you have to put this in alphabetical order. So bromo is before chloro. So it's 5 bromo on the 5th carbon, 6 chloro, 3 methyl, hexane 1-al. So it's hexanal. So it's 5 bromo, 6 chloro, 3 methyl hexanal, the aldehyde with a double bond OH, double bond OH. Then carboxylic acid, where we've got a double bond OH. We also have, right, so this is important that you don't confuse this. Here's your longest chain. This is your longest chain. Here you've got a ethyl. Here you've got a methyl. Now, it is important that you order this in an alphabetical order, right? So it's both on 3, but you have to distinguish between the two in an alphabetical order. So you have to separate it in the naming to acknowledge the alphabetical order. E becomes, E on the alphabet is before M. So it's 3-ethyl. So this is 3-ethyl. 3-methyl. This is your methyl. Pent, your root word, your 5 carbons. Oic acid. So it's penton, 1-oic acid. So it's 3-ethyl, 3-methyl pentanoic acid. Right, so your oic acid, the functional group is at the first carbon. So it's pentanoic acid. Remember, it's oic acid. And you have to acknowledge this, that you put it in alphabetical order. That's why I underlined it with red here. The E is before the M on the at the alphabet, in the alphabet. Right, so this is an aldehyde, C double bond OH, and this is a carboxylic acid, C double bond OH, the one being oic acid, the other one being L. Remember, OH is the alcohol being ol. Right, here's another example of an aldehyde. On the left side in this example, and we started numbering there. On the 3rd carbon, we've got 1 branch. So this is easy then. It's 3-methyl butanol. Sorry, 3-methyl butanol, being only 4 carbons. It's button L. Remember, the aldehyde's suffix is L. We could have written it as button 1L or butanol, because it will always be at the first carbon. Remember the difference between an aldehyde and the ketone, what I wrote here. Ketone is always between 2 carbons, and the aldehyde is always at the terminal site. So that's why it will be butanol there, or button 1L. Right, here's a ketone example. So here's 5 carbons. We've got 1 branch, and we've got the functional group here at carbon number 2. Remember, we said in the beginning that a ketone always needs to have at least 3 carbons. So here we've got 5 carbons, and the branch group is at carbon number 4. So it's 4-methyl pentan 1-one. Remember the ketone, look at the last 3 letters here, -one, the suffix is -one. So it's 4-methyl pentan 2-one. So it's pentan 2-one being on the 2nd carbon. Right. Another example here that I just got, this is, I actually looked for examples in the exam and test on the internet, and really the examples that I got there was fairly easy. I couldn't believe it. I couldn't find difficult ones, so I just wrote these 3 down. Really, if you go through all 5 parts, if you go through all 4 parts, and then you look at the way that I started adding the different branches, you'll really do very well in organic chemistry. So yes, I wrote this down, and then I stopped searching. I actually didn't look at a lot. I looked at about 3 or 4 examples of a test and previous exams. The one was 2016, and I think I looked at it 2021 as well at a test where they actually give the examples, and you have to identify or name the IUPAC names or give the structures. And I I took these examples out from there. So if you look at this one that I got from one of those examples, here they have 3 attachments of 1 carbon each, right? So it's 3 methyls, right? But it's on locations is at carbon 2, and then 2 of them at carbon 4. The functional group here being an alkene. So you have to number it from the left side. So this is your longest chain, right? So then it is a pentane or pentene, because it's a double bond. It's pentene, sorry, not pentane, it's pentene. And then your branch groups, there's 3 of them, similar ones. So therefore it's trimethyl, but it's located on 2, on 4, and on 4. This I got from a multiple choice question, and then they had this all mixed up. Very similar, but with slight difference. So you have to make sure that you identify the locations, all 3, and that you have to acknowledge that these 2 are separate on carbon 4. So it's 2, 4, 4, trimethyl, pent, 2-ene. Right, so your functional group is at the 2nd carbon. So it's 2, 4, 4, trimethyl, pent, 2-ene. Right, so this was one of the multiple choice questions. Then this one I also got there, where they, this is an example, right, where they numbered this from the left side. So because of this branch, right, you have to number it from the left side, because you can see bromine here is closer to the left than to the right. So it's from the left side. That's 1 up to 6. So it's going to be hex. It's single bond, so it's hexane, ane. It's an alkane. Then you've got your bromo. Remember we said bromo, chloro, fluoro, iodo is part of the prefix in your naming of your compound. So it's 3 bromo, 2 ethyl hexane. Right, so this is also actually clear, but you can maybe make a mistake in these 2 attachments here. So it's 3 bromo, 2 ethyl hexane. Right, this was another example I got, and I decided to quickly write it in. So at the 2nd carbon and at the 3rd carbon, you've got 2 attachments with 1 carbon each. So it's ethyl, but it's not ethyl, methyl, but it's dimethyl, and it's 4 carbons. And so it's but, and it's single bond, so it's ane. So it's 2,3 dimethyl butane. Right. So yeah, I just write down a summary of the rules. You have to identify the longest chain. The functional group must be in the chain. So you count the functional group as part of the longest chain. The chain does not need to be straight, right? The chain can have a bend up or down. It doesn't necessarily need to be straight. We didn't do examples, unfortunately, of that, but all the attachments, all the branches must be put in alphabetical order. And then you must note that bromo, fluoro, chloro, iodo is part of the prefix in the naming. All right. And the substituents takes the lowest number, but the functional group gets preference. Okay. Remember, fluoro must have a U there. All right, I see it doesn't have a U, so please remember fluoro is F-L-O-U-R-O, not F-L-O-R-O. This looks like fluoromargarine. So it's F-L-O-U-R-O. Bromo, fluoro, chloro, iodo is part of the prefix. Fluoro, F-L-O-U-R-O. Right, so yes, I hope you enjoy this, and really, I looked at the question papers and the test. I also repeated 2021. I got some of it on the internet, and really the chemistry part, you can really score high marks. It is not difficult what they ask in the chemistry. But thank you that I could share all of this with you.